Why use reinforcement learning to optimize power grids? Imagine a power grid that learns and adapts on its own, balancing energy supply and demand perfectly without human intervention. That's what reinforcement learning can do for energy systems. This form of artificial intelligence involves an agent that makes decisions by interacting with its environment and getting feedback in the form of rewards or penalties. Over time, it learns to make smarter choices, just like how a robot learns to perform tasks through trial and error. In power grids, reinforcement learning helps manage how energy is generated, stored, and distributed, especially when conditions change quickly. Renewable energy sources like solar and wind are great but unpredictable. Reinforcement learning can adjust the operation of batteries and other resources to store excess energy during low demand and releases it when needed. This reduces waste and makes renewable energy use more efficient. It also improves overall operational efficiency by finding solutions close to the best possible ones, saving costs and keeping the grid stable. Because power demand varies throughout the day and weather can change suddenly, reinforcement learning allows the grid to respond in real time without needing detailed programming for every scenario. Another big advantage is that reinforcement learning works well in distributed control systems. Smaller sections of the grid, like microgrids, can optimize locally while coordinating with the larger system. This makes the entire network more resilient, especially during outages or disruptions. Plus, once trained using powerful computers offline, reinforcement learning algorithms can be deployed in the field without needing expensive, real-time calculations. This makes implementation more affordable and practical. In robotics and artificial intelligence, reinforcement learning is used for autonomous decision-making in complex environments. Applying it to power grids is similar. Both involve systems that learn from experience to handle uncertainty and change. For example, reinforcement learning can optimize how grid-scale batteries work with solar farms to maximize energy use during peak times. It can also help microgrids operate smoothly during outages or manage, building energy consumption to support the overall grid. This approach turns traditional power systems into smart, self-learning networks that can adapt to future challenges. It's a step toward more sustainable, reliable energy infrastructure that can meet the growing demands of modern society.